Thanks for plugging in. Today we're talking excellence with TE Connectivity and the interconnect specialists from TTI IP&E. It's the news, information, and detail you need to know to stay informed about the latest innovations in all types of electronics connectivity.
Thank you, Jim. And hello, everyone, and thanks for joining us. I'm Gabe Osorio, Transportation Marketing Manager at TTI, and your host for this episode of Talking Excellence with TTI and TE Connectivity. Today, our guest is Shane Lauth, and we're going to talk performance engineering as it pertains to protecting next-gen technologies. Shane, that's kind of a mouthful. Tell us about your role at TE and what you do that helps define the future of electric vehicles.
Yeah, thanks, Gabe. I'm happy to, and thanks for having me. So I'm Shane Lauth, and I lead the global product management team in TE's performance materials business. So here we focus on solutions like heat shrink tubing, EMI shielding, and sealing. So in my role, I'm responsible for the overall portfolio and product strategy globally. So everything from business planning to new product development, really making sure we're delivering solutions that our customers need. I've been with TE for a number of years now. I've also worked in our sensors business and in corporate strategy. So overall, I've spent a lot of time at the intersection of technology, strategy, and customer applications, which is, that's what brings me here to this conversation today.
Very good. Thank you, Shane. I want to jump into, this idea that protection is inseparable from connectivity, especially in next-gen vehicles. In your opinion, what are the considerations there for the design engineer?
Yeah, it's a great question, and it's a really important place to start. And I think maybe before jumping into the meat of it, I think it's important to step back and just talk about the changes that we see in vehicles right now, right? Because there's a lot going on. So one, you've got higher voltages, right? So even though you can look at it and say, EV adoption hasn't quite accelerated as quickly as expected, we still see our customers working on next gen high voltage system development. That's continuing to move forward, right? Second, you have a lot more data in the vehicle, right? Whether it's just infotainment and convenience features to more advanced sensors, cameras, autonomous systems. So there's really a much bigger data load within the vehicle to manage. And on top of that, you've got entirely new electrical architectures, which are changing the overall system layout. So kind of altogether, we see that increasing system complexity. And in that environment, protection, it's not just optional, right? It really becomes critical. So from a design perspective, you start to see that pretty quickly. You've just got a tighter packaging environment. You've got higher power densities, higher data speeds, and a lot of these running more closely together. So things like insulation, shielding, and sealing, they're not just nice to have. It's actually what you need to ensure your system works as it's supposed to in the real world. So within our performance materials business, that's exactly what we're focused on, right? So we're developing heat shrink tubing and EMI shielding products that are really all about protecting against all those stresses we talked about, managing heat, electrical stress, data interference, so the system stays reliable over time. And that's the big point, right? As you mentioned, connectivity and protection, they have to be designed together because if protection is just an afterthought, you might have something that works on paper, but it's just not going to hold up in real world conditions, whether it's temperature, vibration, moisture, or otherwise.
Yeah, and to your point, it's the real increase of overall device content and connectivity within vehicles today too, right? We're only getting more electrified or electronified within the cab, and even thinking obviously about a fully electric vehicle beyond that, and all the challenges that certainly stem from that. So the great answer, fascinating to think about as well. As I kind of made a note to myself, and I'm glad that the next question really pertains to this around zonal and or centralized vehicle architectures. How do protection needs change or evolve with those two competing, or maybe not competing, but two optional vehicle architectures, with obviously more vehicles migrating to a zonal architecture versus that centralized vehicle architecture?
Yeah, it's a really important question. And I think I'll primarily talk about this from an EMI standpoint, although there are certainly other considerations. So,
sure,
we see zonal and centralized computing really working together in a lot of ways. So you might be pushing that compute load out to those different zones. And in those architectures, it really just raised the bar on EMI protection. So what happens is you're starting to consolidate kind of power and high data rates into these smaller zones, and you're really increasing signal density, and it just creates a lot more opportunities for crosstalk and interference. So, and you start to see that play out pretty quickly in a design. So again, you've got very high data speeds, maybe higher powers and voltages, running more closely together than before. And as these data rates start to get into even the multi-gig range in some applications, even a small amount of noise can really start to cause some issues, whether it's just signal distortion, errors, or latency issues, or other issues you might see from an EMI perspective. So the question really does become, how do you kind of maintain and protect that signal integrity in what's essentially just a more crowded electrical and noisy environment, right? So, and that's where shielding becomes a system level enabler. It's not just about blocking interference. It's about making sure the system performs the way it's supposed to and make it perform consistently over a long duration of time. So, if you're a design engineer, that really shows up in the details, right? So how are you routing certain components and systems? How are you managing separation and your tolerancing? How is the shielding integrated into the overall system architecture? Because without that, these next generation designs, they just won't deliver the performance that they're targeting on paper.
Yeah, great point. And you kind of triggered a question, an additional question in my mind here, Shane. In terms of the products that your group has from an EMI shielding and some of the other, I'll say, protection products, how much of a role does material makeup of the product itself that you guys are working to protect and or block noise from play a difference? Meaning, if it's plastic, if it's metal, if it's rubber or nylon or something along those lines. I mean, is there a big consideration that's taken into account around that as well too, in terms of maybe product selection or an additional consideration that needs to be made there?
Yeah, absolutely. I mean, I'm within our what we call performance materials business. We really are a collection of material science driven product lines, and really what our products do. The basis for it is typically in that product formulation itself. So these products are designed and formulated specifically to meet whatever application, environments that they might see. And it gets to some of the technologies we also use, whether it's across EMI shielding or across heat shrink tubing, something like cross-linking. So we do either radiation cross-linking or even chemical cross-linking to most of our materials. And that's really about improving the overall performance of those materials. So you get, whether it's better temperature resistance, just better mechanical strength, just better long-term durability. And in the case of heat shrink tubing, actually the cross-linking is what gives it that shape memory effect, so it can actually shrink and conform tightly around components. So the formulation of the materials, whether it's a heat shrink tube, an EMI gasket, or otherwise, that formulation really is typically what's giving it the underlying performance requirements needed for that application.
Thank you. Yeah, that makes a lot of sense. Looking to EMC, what role does shielding materials or do shielding materials play in achieving EMC compliance in next-gen electrical architectures?
Yeah, it's a great question, and I wouldn't position myself as the EMI technical expert. We do have a deep team of engineers who focus on it every day, but I think it's good to share my perspective on kind of what we're hearing from our customers and some of the problems that we're really focused on right now. So, I mean, firstly, what we're seeing is that shielding is just becoming much more critical in that higher data rate and higher, voltage environment that we've talked about. And we start talking about these high speeds we're seeing in vehicles today. There's just such little room for error that even just a small amount of noise or interference really starts to impact performance pretty significantly. So what we hear consistently from customers is that power and high-speed data are increasingly running in close proximity, and managing the interference has become a real challenge. So from an EMC compliance standpoint, that's showing up. One of the things we really see a lot is designs being harder to pass on the first try, right? So as you got these more complex systems, but you also have OEM requirements or even, system integrator requirements, getting systems to pass on that first go, it can be very, very tough. And that's where we really see it's critical to focus on EMC compliance really from the get-go, right? Because if you don't plan for early and you don't get that designed in correctly and you're trying to troubleshoot late in the process, it's just something that is going to typically add cost, add complexity. Sometimes we joke about what we see as maybe a Frankenstein solution where it wasn't designed to be that way, but it had to be developed that way to manage something that came up in validation or elsewhere, right? So that's really one of the things that we try to avoid by working early with our customers.
So what I'm hearing then, it's the right strategy behind design of these devices or these architectures is to include that consideration for probably both EMI and EMC. The earlier the better in the design phase process, I would assume, right?
Yeah, absolutely. And I think and maybe just to explain kind of EMI versus EMC, right? So EMI, we're talking about electromagnetic interference, right? So that's, let's say unwanted electrical noise that might interfere with the systems. And EMC is really around that electromagnetic compatibility. So it's the way I think about it is EMI is the problem, the unwanted interference, and EMC and being EMC compliant, that's the goal. And that's what we're here to help our customers solve and making sure their systems work together without interference and they work as designed.
Thank you. Yeah, good explanation for that. Thinking of the markets that I'm assuming you get to kind of be a part of and help serve, how do protection needs differ across automotive applications and then your more traditional, ICT or industrial commercial transportation, needs? How do those differ, or those two markets kind of differ?
Yeah, and I'd say there actually are a lot of similarities between automotive and commercial transportation, but there's definitely some differences as well that become really important in terms of how you're designing protection solutions. So firstly, both operate in what I consider pretty harsh environments, right? So you need long-term reliability, long-term protection, designing for 1-2 decades in very demanding applications. In automotive, I'd say the harshness comes in a lot of different forms. So what you really see is a lot of what I think of as motion and just general environmental exposure, right? So you've got constant vibration, thermal cycling, and then all the nasty, things that you're going to see on the road, right? Whether it's road salt, fluids and moisture, debris, things like that could impact your system. So protection has to be very robust mechanically while still providing insulation and sealing over time. Now, in commercial transportation, whether it's trucks, buses, construction, and agriculture equipment, you get a lot of those same challenges, but often at a different scale. So, you might be dealing with higher voltages, higher operating temperatures, in many cases, just a heavier power load or more, constant duty cycle. So it tends to be a more extreme version of that automotive environment we talked about. So both environments are definitely tough, but we see some differences. And in automotive, again, it's more about managing kind of the motion, vibration, some of the emerging, high voltage architectures that we talked about. While in commercial transportation, it tends to push more onto the edges of the electrical and thermal stressing that we would see across our customer base. And so, what that means from a design engineer perspective, it's really just tailoring the protection strategy to the application and understanding, what specifically that system might see over its operating lifetime and selecting materials and solutions that can meet that over the full life of the vehicle.
Yeah, thank you. That makes a lot of sense. For my last question, what I really want to know or wanted to ask was specifically for the materials or technologies that are needed, in the harshest, vibrations and fluid exposed applications. What are those specific materials or technologies that should be used or are needed for those type of applications?
Yep, it's a really important question. And when you get into these harshest of environments, whether it's just vibration or fluid or otherwise, it really comes down to that material selection is really, really key. And when we look at it, right, we're looking at long-term reliability and durability across electrical, mechanical, environmental protection, a number of factors, right? So there's a lot to consider there. So, and I'd say the real challenge is the combination of stresses, right? It's not just that, hey, we've got a high temperature environment. You probably also have high temperature with vibration, with exposure to oils, coolants, other contaminants over long periods. And so that's where, the material science basis of our products comes in, right? So as I mentioned before, we've got specific formulations and different materials to use, for example, in our heat shrink tubing. if you need something that is not going to see a too harsh of an environment, you need it to be moderately flexible. We've got, formulations for that. If you need something that's going to provide strain relief on a connector back shell and seal at, high temperatures and high voltage and have a long lifespan, we've got certain material formulations that are going to be used for that. And we mentioned the cross-linking as well, right? So that's just an important technology and capability that we use across our EMI and our heat shrink products to really make sure that those solutions are enabled for long-term durability. Within heat shrink tubing, you also see what I would call multi-layer solutions. So we have dual wall tubing, it's got an adhesive liner inside of the jacket. So as you shrink and recover that tube, it's got that adhesive liner, which is going to melt and flow and provide some extra environmental sealing. And that can, range in a number of different applications, from just a single substrate to a large wire bundle that might need, much more significant sealing. So that's especially important in fluid exposed areas where you just got to keep moisture and other contaminants out. And stepping back, right, I think it really comes down to choosing the right combination of solutions. Whether that application needs insulation, sealing, shielding, all of the above, right? It could be heat shrink, it could be an EMI gasket that's made out of a special formulation. It could be a multi-function product, right? And each of those is going to play a specific role in that application to meet those application requirements. And the key is really making sure everything kind of works together, because in a harsh environment, it's not just one stress, right? It's everything happening at once. And that's where, the material selection, getting it right up front really makes the difference.
Yeah, that's very important. Thanks for that answer, Shane. I think, what it really tells me, and hopefully to the audience as well too, is that TE has certainly the knowledge, the engineering knowledge, the products, the materials, all available to help solve these, protection issues or protection design challenges truly in multiple different, I'll say, transportation markets. So thank you very much for that explanation. And Shane, we definitely appreciate you taking time out of your day today to share your expertise here on Talking Excellence. And thanks to everyone listening in. Please be sure you subscribe on your favorite podcast platform for our next episode. And until then, thanks for plugging in to Talking Excellence with TTI and TE Connectivity.
That's it for this episode of Talking Excellence. Join us next time for the podcast that brings together the specialists of TTI with the connectivity experts from TE, an insightful conversation about getting connected.